Hi, my name is Jedler,
And I'm Carl.
and today we'll be talking about torque vectoring. So, what is torque vectoring?
That's a good question, Jedler. Torque vectoring is essentially a system that allows the car to transfer or control how the torque is distributed within a given tire or the axles. Basically, the way it can be achieved is either with a mechanical differential or with an actual electronically controlled device. To begin with, there are several torque distribution systems. I decided to focus on two of them, with the main focus being on torque vectoring. So Jedler, have you ever heard of LSD?
Yeah, actually, LSD stands for limited slip differential. So, the way that system works is that it looks at how much friction happened on each tire and determine how much torque those tires should receive. That's how that system works. Where torque vectoring over here, the way it works is that it gives the car system designer complete control on how much torque each tire should.
You answered that very well. So just to get into a little bit more details, these three squares actually represent torque vectoring differential. So and in this case, sorry, it actually represents a limited slip differential. So your engine is going to apply a torque to this differential, split the 100% of the torque between the two axles. So in other words, 50% of the torque will be sent to this differential and another 50% will be sent to this differential. Again, depending on which tire has the more grip, the one that has the more grip is going to receive the most torque. And now as for torque vectoring, what happens here is actually you as the designer get to have full control of which tire gets which amount of torque.
So, for example, when a car is taking a curve, so this inner radius has a shorter distance to travel compared to this one because it has a greater radius. So, what the designer could do is decide, okay, so since on this side I will have a greater distance, I'll be able to give the tires different torques just based on that information. Another thing that we're gonna talk about is in-wheel motor system.
So essentially what this would be is instead of having an actual conventional engine, what would happen is that the motor itself would actually be placed in each tire.
So the cool thing about this is that it won't need the traditional axle anymore. So what benefits that gives is that each tire will have their own power, meaning it won't be split between tires anymore. Each of them would have their own torque. And another cool thing is that because there's no axle, the system is making the decision on how much torque to apply. It gets to the tire faster because now the motor is directly in the tire. That means when you turn, it automatically gets the amount of power. It doesn't have the time to think. Because here, when you have the axle, it actually had to drive all the way down here and then get differentiated between the two tires. That's a cool thing. But the in-wheel motor has different advantages and disadvantages. Do you know some of those advantages?
Yeah, definitely. I mean, just from the fact that everything would be in that tire, like you said, because it gets that signal faster, that means stability is attained easier. Handling becomes much easier as well, and due to that, it makes it a more efficient drive. And on top of that, the fact that the engine and the motor is not under the hood, it makes it more spacious for the car, right? However, there are disadvantages. It's extremely expensive, and definitely complex as well because we're talking about control systems here. Which means that there's a controller needed to control each tire. To conclude this video, what we did today was take a look at LSD, then we took a look at torque vectoring. We concluded that torque vectoring had the better system in terms of torque management. And now if you take that torque vectoring and you put it in and you combine that with the in-wheel motor system, you actually end up getting the ultimate car, which means that we get ultimate stability, ultimate handling and ultimate performance. So that being said, it concludes our video for today.
Thank you guys.
Thank you guys so much.